Assalamu alaikum students, how are you? Today we are going to do exercise of chapter number 4, magnets and electromagnets. Question number 1, multiple choice questions. First statement, where on a magnet is the magnetic field strongest? Option A, at both north and south poles. Option B, at the north pole. Option C, at the south pole. Option D, in the middle. The correct option is A, at both north and south poles. Statement number 2, what will a suspended bar magnet do? Option A, spin round and round. B, point east west. Option C, point north south. Option D, point vertically downwards. The correct option is C, point north south. Statement number 3, what happens if the north poles of two bar magnets are brought close together? Option A, the magnets move together. B, the magnets move away from each other. C, the magnets stop being magnetic. D, nothing happens. The correct option is B, the magnets move away from each other because the like poles repel each other. Statement number 4, what happens if the north pole of one bar magnet is brought close to the south pole of another bar magnet? Option A, the magnets move together. B, the magnets move away from each other. C, the magnets stop being magnetic. D, nothing happens. The correct option is A, the magnets move together because unlike poles attract each other. Statement number 5, an iron bar can be magnetized by option A, hitting it with a permanent magnet. B, putting it alongside a permanent magnet. C, putting it on the end of a permanent magnet. D, stroking it with a permanent magnet. Correct option is D, stroking it with a permanent magnet. Question number 2, true or false? Statement number 1, any metal alloy that contains iron will make a good permanent magnet. This is true statement. Statement number 2, a compass held near to a wire carrying an electric current will always point north. This is wrong statement, false statement. Statement number 3, the strength of the magnetic field in a solenoid can be increased by increasing current, making more loops in the coil, and putting a rod of steel inside the coil to stop it collapsing. This is also true statement. Statement number 4, electromagnetism can be used in many devices such as loudspeakers and electric motors. This statement is true. Statement number 5, the recording material on a hard disk is magnetic. This is true statement. Question number 3, a student has a magnetic compass. He also has 3 metal bars painted to look same. One is copper, one is unmagnetized iron, and the other is a permanent magnet. Describe how he can find out which bar is the magnet. Beta, the answer is that the student places the compass close to all the 3 metal bars. The copper bar and the iron bar will cause no response from the compass needle. When placed along the permanent magnet, the compass needle will align itself according to the poles of the magnet.
Start.
Question number 4. The diagram shows a piece of iron held by attraction to a magnet. This is magnet having north and south pole. This is the piece of iron that is held by the attraction to a magnet. Part 1. Mark on the iron where the induced north and south poles are. Beta, north pole will be here and south pole will be at this end, opposite to north pole. Question number 4, part 2. One theory of magnetism uses the idea that iron contains tiny molecular magnets which can line up in magnetic fields. Use this theory to explain how an unmagnetized iron bar is attracted to a magnet. The answer is, when a magnet is placed near an unmagnetized iron bar, the molecular magnets in the bar line up in groups to form domains. These domains are sensitive to magnetic field. As a result, the iron becomes magnetized. Question number 5, part 1. Describe briefly 2 ways of turning an unmagnetized steel rod into a permanent magnet. The answer will start from this line and it is on page number 52. A better way of making a permanent magnet is to place the steel inside a coil of wire. When an electric current flows in the coil, strong magnetic poles are induced in the steel, along with this diagram. Question number 5, part 2. Describe briefly 2 ways of demagnetizing a steel rod which has become magnetized. The answer will start from this line on page number 51. A permanent magnet can be demagnetized by heating it up and then quickly cooling it in cold water, along with this diagram. Energy from heating causes the molecule to move faster. Domains become unaligned. Second method is hitting a magnet with a hammer or simply dropping it onto the hard floor will demagnetize a permanent magnet. Thank you.